Now we want to plot the graph of what? Plot the graph of x squared plus 6x plus 5 equals 0. Somebody is saying, is there a range given? No range of value of x. So what are we going to do? Well, to do this, if you find yourself in this situation, you want to plot the graph, right? But there's nothing given at all. And then you don't assume in the world of maths. No assumption. Assumption is not allowed. Assumption is not allowed. Don't overwork your brain. So what do you then do? Of course, simple. What you need to do is just to, number one, convert this given quadratic equation from this standard form to vertex form. And that is the first thing I want to do, right? That's the first thing I'm thinking of doing. I will convert the given quadratic equation from standard form to vertex form. And of course, let's just play around that. Playing around this now, you write it as x squared plus 6x plus 5 equals 0. So from there, that will be x squared plus 6x, then plus 5 equals 0. The half of this, square it, add it to this, and add a minus. That will be x squared plus 6s plus 3 square minus 3 square plus 5 equals 0. And then with that, what you have, this is square, union of squares, that will be x plus 3 of squared, then minus 9 plus 5 equals 0. So we have x plus 3 all squared, then minus 4 equals 0. So writing it, compare this equation here to the form a into bracket s minus h all squared plus k equals 0. So comparing a is 1, s is s, minus plus 3 equals to minus h. So h will be what? Minus 3. So the vertex is actually minus 3, comparing this to this, k is what? Minus 4. So that is the vertex of this given quadratic equation. Then how will I plot the graph given the vertex? And what's the vertex of a curve? The vertex of the curve is the tip, the turning point, either the maximum or the minimum. Of course, I'm going to talk about that very soon. Maybe I will need to talk about that here. Given a standard quadratic equation, how do I know the behavior of the curve? Are you get what I'm saying? Of course, I will tell you that real quick. Let me tell you that real quick. Let me talk about this. Now, if they give you a quadratic equation on the form ax squared plus bx plus c equals 0, where a is greater than 0, that is the leading coefficient is positive, then your curve will be like this. Are we here? That's how your curve is going to look like. It will be U-shaped. And this point is what we call the vertex. This is the vertex of the curve. Are you there? That point is called the vertex. Why, if they give you something of this nature, if it is still the same equation, let's say you have ax squared plus bx plus c equals 0. And then your a is negative 0. Are you here? A is negative 0. Then in that situation, your curve is going to be like this. Are you there? Your curve is going to be like this. That's inverted N shape. So inverted U. So if the leading coefficient is positive, it's going to be U shape. If the leading coefficient is negative, that's going to be V shape. Sorry, it will be inverted U shape. And this point here is called the vertex. That point there is called the vertex. And this point here too is called the vertex of the curve. Note that about vertex. Altogether here, the vertex is the tip. And the vertex, you determine it directly with just your h, k here. That will give you the vertex directly. No stress. You get the vertex directly just by that. I get what I'm saying now. And the beauty of this vertex, right? The beauty of this vertex, don't mind me. The beauty of this vertex is that this here is so beautiful. Why? Because it will not only tell you the turning point of the curve, it will give you, this one will tell me, it will give me the maximum or the minimum point of the curve depending on the kind of curve it is. If your curve is N-shaped, it will have a maximum point. If your curve is U-shaped, it will have a minimum point. Are you here? If it is N-shaped, it will have a maximum point. If it is U-shaped, it will have a minimum point. I said we want to plot the graph of this. So let's go real quick to that. Let's go to that without wasting much of our time. So we want to plot the graph of what? Now we have a turning point. That's what I want to look at. Now the turning point is minus 3 and then minus 4, minus 3, minus 4, minus 3, minus 4. So that's minus 3 in the x-axis and minus 4 in the y-axis. Don't mind me, I gotta produce something a little bit more beautiful. So this is, let me make it minus 1 here, minus 2, minus 3. And this is minus 1, minus 2, minus 3, minus 4. Ah, shit. Don't mind me, this will not work. This will not work. I have my reason. Let me redraw it. Let me push it a bit. Sorry. Okay, just manage it, don't mind me. So we have 1, 2, minus 1, minus 2, minus 3, minus 4, minus 5, and this is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Are we there? This is 1 here, please. 1. And this is 2. Now let me make it unique in the sense that I want to look for something beautiful, a little bit colorful, yeah? Okay, now we're good. Now we want to plot the curve of this. You know, don't forget our turning point is what? Minus 3 on the x-axis and minus 4. Minus 3, minus 4. That's the vertex. Don't forget that. You don't forget that in a hurry. The vertex is minus 3, minus 4. This one here. Minus 3, minus 4. Minus 3, minus 4. Minus 3, minus 4. It's a thing we can still extend a little bit downward, but I think this point to be enough for us to plot our curve. Minus 3, minus 4. Minus 3 on the x, minus 4. That will be these points. Are we getting what I'm saying now? Minus 3, minus 4. Then what you now go is that you'll be going left and right. You get what I'm saying now? Okay. Minus 3 on the x, minus 4 on the y. Sorry, this should be minus 3 on the x, minus 4 on the y. Minus 3, minus 4. This should be this point here. Are we here? Now, the way you now go is that from minus 3, think of a number line. And then you have this point to be minus 3. There you have minus 4, minus 2. Again, you go minus 5, minus 1. Just that 2 points is what we need. Are we here? Just that 2 points. Okay, with just that 2 points, if I pick, I would together now, I'll drop minus 3 into this thing you got here. Minus 3 into this beautiful thing. You can drop it into this beautiful expression here. So I'll put minus 3 into that. If I put minus 3 here, minus 3 plus 3, that's what? That's 0, that's the vertex. Okay, I said I will go. The next point after minus 3 is what? Minus 4. Now if I put minus 4 here, that will be minus 4 plus 3 all squared, then minus 4. Minus 4 plus 3 all squared, and then minus 4. I'm putting it into this equation. Let me look for a way of erasing this. Oh, this one, we can no longer erase it, so let me leave it. So I'm putting it into this equation here, right? This equation here. X plus 3 all squared minus 4. So I'll pick the next point. The next point here on the number line, the next point is what? Minus 4 to the left. So if I pick minus 4 to the left, what do I have? With minus 4 now, that will be putting minus 4 instead of x. So that will be minus 4 plus 3 all squared. Minus 4 plus 3 is minus 1. Minus 1 squared. That's this one is minus here. Sorry, this is minus here. Minus 4 plus 3. That's minus 1. Minus 1 squared is 1. 1 minus 4 is actually what? Minus 3. Let's leave that. Let's think of another point. Okay, I'm still somehow far from it. Okay, very good. I can then, the next point, I've picked my value to the left, then to the right. After minus 3, I have minus 2. So let me pick minus 2, fix it into it. Now, minus 2 plus 3 all squared, then minus 4. We are putting it into this thing you get here. This thing is the benchmark. In fact, let me write it down here. Let me write it down here so that you not be asking me too much. I want to write it around here. That will be x, I guess is that not plus 3 all squared, then minus 4 equals 0. That's it. So when s is, I go from our reference point is what? Minus 3, comma minus 4. So this is the point, s coordinate. Leave the y coordinate. I get what I'm saying? We are going left and right along the x. So I have minus 3. The next point is minus 4. I've done for that. And now I'm going to the right, minus 2. After that, I'll go for minus 5. Then I'll go to minus 1. Are you getting what I'm saying? So that is that. So real quick, we say, so this one, minus 2 plus 1, that's 1. 1 square is 1. Minus 4, and then I get what? Minus 3. Again, let's go to the left again, minus 5. Minus 5 plus 3 square minus 4. Minus 5 plus 3, that's minus 2. Minus 2 square minus 4. Minus 2 square is what? 4. 4 minus 4 is 0. Then the next one we go to what? Minus 1. Minus 1 plus 3 all squared, then minus 4. Let's see the behavior. Minus 1 plus 2, 3, that's 2. 2 square minus 4, that's 0. So let's pick a point. When this is enough, at the point when we inserted minus 4, we got 3. And at the point minus 2, we got 3. Minus 4. Minus 4. Was it 3 or minus 3? Minus 3. Minus 4 and 3. Minus 4 and 3. That's this point. Then minus 2 and 3. That's this point. Again, minus 5. I think we got 0. Minus 5, 0, and minus 1, 0. Minus 5, we got 0, and minus 1, we got 0. Minus 5, 0, minus 5, 0. That will be on this. And minus 1, we got 0. Minus 1, 0. Should we still make it beautiful? Let's make it beautiful a little bit. Let's pick another point sufficiently. After minus 5, let's go for minus 6 and 0. You know, the next point here, judging by this number line, the next thing we have here is minus 6. After minus 5, minus 6. And after minus 1, we have 0. So let's pick that minus 6 and 0. Minus 6 and 0 into the equation. So our equation is still what? This equation, x plus 3 all squared minus 4. So when s is minus 6, that will be minus 6 plus 3 all squared minus 4. Minus 6 plus 3, that's minus 3. Minus 3 squared is what? 9. Minus 4 is actually what? We say 5. Very good. And let's go for 0. 0 plus 3 all squared. When s is 0, so that will be everything will be 0 plus 3 all squared, then minus 4. That will be 3 squared. That's 9 minus 4, and that is 5. So that's what? It is symmetrical about that point. That's one thing you should note. It is symmetrical about that central point. And then it will be to the left, you're having the same thing. To the right, you have the same thing. So when it is 6, we have 6, 5. So let me number this one. This will be 1. This is 2. This is 3. This is 4. This is 5, 6, 7, 8, 9. So we have 6 and 5. 6 and 5. And I have 0 and 5. Don't mind me. It's because of the way I did it. So I can now plot the curve. The curve will be like this. Look at the curve. Beautiful, isn't it? So beautiful. It's so beautiful. Very, very beautiful. And that is how the curve is going to look like. So I'm able to draw the curve just like that. Just like that. Without any stress. So now about this curve, you notice this is the turning point. And again, let me explain with this. This point here We call it the line of symmetry. We call that line of symmetry. This line here, line of symmetry. And those days when you're in secondary school, at times you plot a curve and then they tell you to find the equation of the line of symmetry. That is just with the vertex we got. Our vertex, which is what? -3, -4. You get to know that this point is also the same as what? The equation of the line of symmetry. So you just say the equation of the line of symmetry is equal to what? X equals -3. That's the equation of the line of symmetry. Another thing we can learn from this thing we did here, another beautiful thing there is that now we can equally get our, if they ask you what's the, this one is U-shaped, so it will have a minimum point. What's the minimum point? The minimum point is what? Point Y equals -4. Because the minimum is related to Y and the maximum is equally related to Y. Why the equation of the line of symmetry is related to X. Are we together here now? So what I would do, right, is that maybe I would drop a question for you guys to do the same thing I did. Plot the graph. Maybe I will drop my WhatsApp number. You can then show me, if possible, your graph doing it this way, right? Thank you very much. God bless you.